Our cosmic weather eye, an ancient fascination. Humans look up always, the sky calls to us. Weather is its voice, sometimes a whisper, calm, sometimes a roar, storm. We have always wondered, what will tomorrow bring? Sun or gathering clouds? This quest is ancient, deep. For millennia we watched, we saw patterns, signs, the color of the sunset, the behavior of animals, the direction of the wind. These were our first clues. Our ancestors needed to know when to plant, when to hunt, when to seek shelter. Now, weather touches every life, it shapes our world, our days. A gentle rain can be a blessing, a fierce hurricane, a terror. Understanding it is not just curiosity, it is about survival, prosperity. It is about navigating our planet, this beautiful, dynamic Earth, our home in the cosmos. So how do we do it? How do we predict the unpredictable? It is a story of science, of observation, of mathematics, of incredible technology. Join me on a journey into the heart of the storm, into the science of weather, the science of tomorrow's sky. Earth's restless blanket, the atmosphere at work. Imagine Earth, a blue marble wrapped in a thin blanket. This blanket is the atmosphere, a swirling ocean of gases, mostly nitrogen and oxygen, but also water vapor, dust. These are the ingredients, the stuff of weather. It is always in motion, temperature is key, it measures the energy, the jiggling of air molecules. Pressure is the weight of air, pushing down on us all around. Humidity is water in the air, invisible, until it forms clouds. Wind is air on the move, from high pressure to low. The sun is the ultimate engine, our star, 93 million miles away. Its energy fuels everything, it warms the Earth, unevenly. The equator gets more sun, the poles get less. This difference creates currents in the air, in the oceans, driving weather systems, globally. Water plays a starring role. It exists as ice, as liquid, as gas. It evaporates from oceans, lakes, rises, cools, condenses, forms tiny droplets or ice crystals. Millions gather, a cloud is born. When heavy enough, they fall. Rain, snow, sleet, hail, the great water cycle, always turning. Sentinels in orbit, satellites charting the chaos. To see the whole picture, we needed to go high, very high, into space. Weather satellites are our eyes, orbiting far above the clouds. They give us a global view, a constant watch, day and night, seeing weather patterns unfold across continents, across oceans. How do they see? Not just with ordinary cameras, they use special sensors, detecting different kinds of light. Visible light shows us clouds, like our eyes see them. Infrared light shows temperature. Warm clouds, cold clouds, land, sea. Microwave sensors see through clouds, measuring rain, wind over oceans. Some satellites stay put. In geostationary orbit, they hover over one spot, watching the same region always. Perfect for tracking hurricanes or big storm systems moving. Others orbit pole to pole, closer to Earth, scanning strips, giving detailed views of everywhere. The data streams down, constantly. A torrent of information, images of swirling storms, measurements of cloud top heights, sea surface temperatures, ice cover. All this feeds our knowledge, it feeds the computer models, helping us understand the present, so we can predict the future. The dance of atmospheric forces. Probing the vertical realm, balloons and radars gaze, satellites see from above. But weather happens in 3 dimensions. We need to know what's happening. Up through the atmosphere's layers. Enter the humble weather balloon, a simple tool, yet vital. Released twice a day, worldwide, from hundreds of locations, a coordinated global effort. The balloon carries a small package called a radiosonde. It's clever. As it rises, it measures temperature, air pressure, humidity, wind speed, wind direction at many different altitudes. It radios this data back to Earth, a vertical slice of the atmosphere, until the balloon bursts. High up, the sonde parachutes back down. On the ground, radar watches, especially for rain and storms. Doppler radar is a marvel. It sends out radio waves. These waves bounce off raindrops, snowflakes, hailstones, even insects. The returning signal tells us where the precipitation is, how heavy it is, and more. If it's moving towards us, or away. This network of instruments, balloons, radar, ground stations, complements the view from space. They provide the ground truth, the essential details. All this data flows together, creating a snapshot in time, the current state of the weather. This is the starting point for any weather forecast. Section 5. Numbers into nature, supercomputers, decoding the skies. The atmosphere is complex, wild, a chaotic system, always changing. Predicting its future is hard, like predicting a billion billiard balls, all bouncing off each other. Tiny changes can have big effects, the famous butterfly effect. So how do we even try? With mathematics and immense power, we use numerical weather prediction, or NWP. It sounds complicated, but the idea is straightforward. The atmosphere follows laws. The laws of physics, fluid dynamics, and thermodynamics. These laws can be written as mathematical equations, dozens of them, all linked, describing how air moves, heats, and cools. Solving these equations is the challenge. They are far too complex for any human to do by hand. We need help, big help. Enter the supercomputer, giants of calculation. They can perform billions, trillions of calculations every second. They divide the Earth and atmosphere into a vast three-dimensional grid. For each point on this grid, the computer takes current data from satellites, balloons, and radar. This is the starting condition. Then it steps forward in time, solving the equations again and again, minute by minute, hour by hour, projecting the weather days ahead. This is how a forecast is born, from numbers into nature's story. Section 6. More than small talk. Why weather wisdom matters. Why do we invest so much time, money, brainpower in forecasting the weather? Is it just so we know whether to take an umbrella? That is part of it, sure. But it's so much more. It is about lives, livelihoods, the safety of our communities. Think about severe weather, hurricanes, tornadoes, floods, blizzards. Accurate forecasts give warning. Time to prepare. Time to evacuate, saving countless lives every year. This is perhaps the greatest gift of modern weather science. The ability to see danger coming and to act before it strikes. A shield against nature's fury. Consider agriculture, our food. Farmers depend on the weather. Forecasts help them decide when to plant seeds, when to water their crops, when to harvest their bounty, protecting against frost or drought, ensuring food reaches our tables. This feeds billions of people, a fundamental human need, and travel. We are a mobile species, aeroplanes in the sky, ships on the seas, cars and trains on land. Weather affects them all. Fog can close airports, storms can endanger ships, ice can make roads treacherous. Forecasts help keep transport safe and efficient, moving people, moving goods, the arteries of our global economy. Section 7, the Learning Sky AI and the Next Forecasting Frontier. The quest for better forecasts never stops. It always evolves. Now, a new tool is emerging. Artificial intelligence, or AI. Machine learning, computers that learn. They are changing the game, opening new possibilities for understanding our atmosphere and predicting its behavior. AI excels at finding patterns hidden in enormous data sets. Weather data is vast, overwhelming. Satellites, radar, model outputs. AI algorithms can sift through it faster, more efficiently than traditional methods alone. They can spot subtle clues that human forecasters might miss, or that current models don't capture. One exciting area is nowcasting, predicting weather in the very near term, the next few minutes, the next hour. Crucial for things like thunderstorms, flash floods, and tornado formation. AI can analyze real-time radar and satellite imagery very quickly to provide more accurate warnings. AI also helps improve existing models by learning from their past mistakes. The future is likely a partnership. Physics-based models and AI working together, hand in hand. AI can help refine the models, fill in gaps, correct biases. It might even discover new physics, new ways the atmosphere works that we haven't yet understood. The learning sky taught by machines, guided by human ingenuity. Section 8. An ever-unfolding map. The future of knowing the weather. We have journeyed far. From ancient sky watchers to the sophisticated science of today. We have seen the atmosphere, its intricate dance of forces. We have seen the tools we use. Satellites, balloons, supercomputers, all working to decode the weather to give us a glimpse of tomorrow. This science is a living thing. It is constantly improving, evolving. Better satellites provide richer data. More powerful computers run finer models. Smarter algorithms learn faster. Each advance pushes the boundary of what we can know, how far ahead we can predict with confidence. The journey of discovery continues. The map of weather is ever unfolding. The impact is profound everywhere. It helps us live safer lives, protecting us from nature's extremes. It supports our economies from farming to flying. It helps us manage resources, water, energy, critically important on our increasingly crowded planet. Weather forecasting is woven into the fabric of modern society. So the next time you check the forecast, remember what's behind it. The dedication of scientists, the power of technology, the pursuit of knowledge. It is a remarkable human achievement to understand such a complex system, to peer into the future even a little. Appreciate the science, the effort, this daily miracle. The weather forecast, our window on a dynamic cosmos.